all. Myself Swati Jalu, Assistant Professor, Department of Listening. I welcome to all to the third day of Atal activity on speech signal processing on using machine learning algorithms. Today's speaker is Dr. G. Yogeshwar Rao. He will deliver lecture on machine learning algorithms for speech signal processing. Before starting this session, first I will introduce Dr. G. Yogeshwar Rao garu. It gives pleasure to introduce Dr. G. Yogeshwar Rao garu. Dr. G. Yogeshwar Rao completed BTech from JNTU Kakinada. He received MTech and PhD degrees from the NIT Tekkali. Currently, he is working as an assistant professor in the Department of ECE-AITAM. His research interests are signal and image processing, communication systems, image analysis, machine learning algorithms, pattern recognition, and computational intelligence. He has published more than 15 journals, including IEEE Transactions in Artificial Intelligence, Springer, and elsewhere. Written 2 chapters in Taylor and Francis. He is a keynote speaker for several FTPs and workshops in various institutes. He is member of IEEE and IETE. Thank you for giving this opportunity.
Very good morning to all. Right. And today's topic is like machine learning algorithms for speech signal processing. Right. I think all of you are ECE background. Right. How many of you feel that this artificial intelligence and machine learning is for the CSC part?
Yes or no?
Yes, right. So I hope while the completion of this seminar, we came to know that this is not related to completely for the CSC or the IT department. It's purely for the, if you know the mathematical knowledge of related to vector algebra and the probability. So even we can, any department student, irrespective of the specialization, we can use the machine learning algorithms for any domain. That's the reason why we are using these ECE people and the CSC people, IT people, mechanical, civil, every department, they are using these algorithms in their applications. While the completion of this session, we all feel that this is not related to CSC or IT, it is related to, if you know the fundamentals of the vector algebra and the probability and a little bit of the linear algebra, we came to know that these algorithms are related to those tasks. Okay, so I will give a quick start for that. Right, we know that what is the importance of this machine learning algorithms and that. Right, so nowadays the automation is gaining momentum. Right, everything will be moving from the automation, so that we are using these machine learning algorithms. Right, so actually, what is the meaning for machine learning? First, we need to train the machines in such a way that will take a decision, right, based on the problems what we are facing, right? So it requires first we need to understand the data, right? So we have a data. First, we need to understand the data. Once we know the clear idea about the data, then we can apply the machine learning. So you can see that there are like 3 different types. What is the supervised, unsupervised, and reinforcement learning. Before that, so machine learning is training a computer, right? How, suppose we have a human being, we have a different experiences of you, right? This is the category of the male, and this is the category of the female, and this is the category of the animals, and this is the category of the birds. How we came to know all these things? Before, we have a trained system in such a way that your parents or your grandparents or some other relatives will tell them this is the features of the bird, so that we can tell that this is the bird. And this is the features of the animal, this having the tails and four legs, so that we came to know that. You see that we came to know that it's an animal. And the same way for the boy and girl. So how that will be trained? Your parents or your grandparents came to that historical data. We came to know that this is the feature. The same way, if you train a mission in such a way that these are the features which are related to human beings, these are the features which are related to an animal, and these are the features which are related to bird, then automatically that mission, if a new data will give that particular mission, it obviously tells that, it gives the results in such a way that these are the features, so that the mission is already trained, we all trained that mission, so that obviously it will give the corresponding result. So the birds is having the wings and all those characters, or those features, or those attributes, then obviously mission will give the same one. So the only point is we need to give that, or we need to train that mission how the human beings are trained. Right? That is the main key funda for the machine learning algorithms. Right? So for that we have three different types of learning algorithms are there. The one is the supervised. The supervised means like you are training a machine in such a way that these are the features which are related to corresponding to a bird. These are the features which are related to an animal. So we are giving the features and the labeling for that. That type of information we can call it as a supervised. Whereas unsupervised, we don't know that anything related to the data. We just give the data to the system, and the system will train automatically. And then the system will come to a conclusion that it will separate the groups of the similar features, and it will give the decision based on the without labeling. That type of is known as the unsupervised. There is another one, it's a reinforcement. That is like an agent will act. So for example, we have a system and we are giving an input to that system. Let us say we are giving a cat image to the system, a machine learning model. And that machine learning model will produce output as a dog. Is it right or not? We are giving an input to the machine learning algorithm as a cat, but it produces an output as a dog. Is it right or not? Obviously it's a wrong. Then what we need to tell that we will take a feedback because it's giving a wrong output. We take a feedback to the system and we are telling that we are giving a wrong output. So that we need to change your algorithm in such a way that we are expecting output as a cat and we need to modify it in such a way. So until unless we will get a exact what we are expecting, that model will be on changing their values. That type of learning we can call it as a reinforcement.
So how we can validate the data then? Suppose in reinforcement learning, we are giving some data, we are getting some output here, but the output may be wrong output. But how we can, how a machine can understand the original output?
Yes, sir. That is actually these reinforcement by learning will come under the artificial neural network. The feed forward networks. Yeah. Yes, sir. So that is actually while the end I will tell that how that works.
Autonomous vehicles driverless vehicles, driver learning car, driver learning aircraft, వాటికి తెలియాలి కదా ఎయిట్ వెళ్ళకూడదు, డెసిషన్ తీసుకోవాలి కదా. అలాంటి డెసిషన్ తీసుకోవడానికి కావాల్సిన అల్గరిథమ్స్ లేదా వాటి గురించి సార్ చెప్పేది. ఆ 3 కేటగిరీలు రాస్తే చూసారా, సార్ చెప్తున్నారు. ఎక్కడైనా మీకు డౌట్ ఉంటే అడగండి సార్, అవసరమైతే 2 తెలుగు ముక్కల్లో కూడా చెప్తారు. ఇదేమి మీకు ఇర్రెలవెంట్ డేటా ఏం కావాలి, కాన్సెప్ట్ ఏం కావాలి.
Right. So in this machine learning mode, like algorithms and all, we have a terminals, different terminals. Like previously I said that supervised, unsupervised, reinforcement. In the same way that AI/ML people, they are using the different terminologies for data types also. One is the training data, validation data, and testing. Right. So we have a data. For that data, we need to train the model. So we require some of the data to train the model. That one we can call it as a training model. It's a data set samples that comprises the input and output values from the AI. Whereas validation is, once if you're training a model, right, we need to check that model, how much the model will be accurately trained or not. After we can try using the validation of that. And after training and validation is over, then we will give a new data to that particular machine learning algorithm. Then the machine learning algorithm produces the responses responding that we can call it as a test. So in some cases, the people may use the validation and test is the reverse manner. We can use the both for the. It's no need for always the validation for the testing of the machine, and test data is for completely new data. Some cases we can use some of the literatures and some of the researchers and they are using, in case of test data they use the validation data, and in case of validation data they use the test data. So it's not
algorithms available for these three also, no? For training data, some algorithms, specific algorithms are available.
yes sir. All these algorithms actually we have a data. That data we need to split it in such a way that training data and then test data or validation. Suppose we have 100 samples. Out of that I can choose a 90% is testing and 10% training and 10% validation. And 80% is 20%. Or 70% 30, 60, 40. Not for 50. Because if you train 50% and you are testing 50%, it may give results also 50. So mostly we can choose as the training data as much as get higher than the testing data. That's the relation. Right? There is no compulsory that we can choose only 80-20 or 90-10 or 60-40. You can use, but only condition is at least as compared to test, train data must be high. Because if you know the more experiences of the model, then only that will give the output as accuracy. Right? Yeah, and next one is the quality of the prediction. So we train a model and then we need to check the quality stuff. So for that we have there is like a overfitting and another one is the underfitting. Most of them they don't know those things. We train a model and we are seeing the results, we are telling that it's giving for the training, it is giving 100% accuracy. But whereas testing, suddenly the accuracy may give for the 30, 40 or 50. They said that no, actually I gave the data, I trained exactly the model, giving 100% training accuracy. Whereas a test data, I need to check a small data, it is giving suddenly for 30% and 40%. That's the problem is the overfitting problem. Meaning is, we trained a model training properly in a biased data. Means that, for example, we have a comparison of in a classroom, there is how many girls and boys we are having. Let us say in that classroom, 99 students are boys and 1 is a girl. Then we train a model with that data. So what will happen if any person will check, obviously the machine will show that it is a boy only. Because we trained the model, it's a completely 90%, 99% of the boy data. So that is the reason this overfitting will happen. It's a biasing of the data. Whereas this underfitting, like the training accuracy itself, we are getting a less value. That we can call it as underfitting. We can modify the algorithm. Once if you change that algorithm, internal parameters and keep on, we get the higher accuracies, we can avoid this. While we are avoiding, how we can avoid this overfitting, we need to train a data in such a way that we need to maintain the equal quantities of the data. Right? So if you want to train a model, okay, the simple example of the boys and girls separation of the data, we need to maintain 50% of the boy features and 50% of the girl features of the data. Then we can train a model. That is the best practice to avoid overfitting. Whereas the underfitting, we need to change that algorithm in such a way that we can avoid the underfitting problem. Right? This is the quality prediction of the data. And now, like people, they are listening these words nowadays like artificial intelligence, machine learning, and deep learning. Right? So actually, what is the difference between artificial intelligence, machine learning, and deep learning? No one knows that. They say that all are same. Right? Artificial intelligence will learn. The same way like machine learning we know. And the deep learning also will do. But what is the difference between the artificial intelligence, machine learning and deep learning? Any idea about that? Right? So actually this AI will start in the 1950s and 70s it was started. These algorithms AI and ML and DL, these algorithms actually they started in the 90s, 50s itself. That's why I'm telling that these are not related to CSC. These algorithms are not related to CSC. Right? So nowadays only we started the CSC with artificial CSC with machine and CSC with data science. But these algorithms were started in the 1950s and 70s itself. Right? So AI started in this 90s, 50s and 70s. Whereas that is like if you train a model, an intelligent decision, artificial intelligence decision, will be like the mission will mimic or will act as a human. How the human beings are trained, the same way that artificial intelligence also will be the decision. And we can go for a machine learning. These algorithms are started in the 1980s and like the 90s and 80s and 90s were started. So the modification of artificial intelligence in here is the same way it is a subset for the artificial intelligence. Machine learning algorithm is a subset for the artificial intelligence. Where we take that the statistical and computer science and AI and the neurosciences, these modifications were incorporated in that algorithm to get a feature for that data. Like the best example, in this artificial intelligence, whatever the data is there, complete data we need to train the model. And then this machine learning algorithms will come to that. Why we need to give the entire data to the machine? Instead of giving the entire data, I know that these are the features which are related to this particular. Like for example, animal is having the 4 legs and tail. That we know that features. That features I can separate and that features I can train a model. Like a human being is having the legs and hands, the body movements and that features already we know that. So if you know the domain features, that domain features statistically we are analyzed and that features we are given to the model. That type of algorithms is known as the machine learning algorithm. And nowadays we have this deep learning. This is also a subset of machine learning algorithm. Which we can see that actually this is the artificial intelligence, where the machine learning is a subset for this artificial intelligence, and the deep learning is the subset for machine learning. This is how the relation between the AI, ML, and DL algorithms. Right? So we know that what is the major difference between the machine learning algorithms and the deep learning algorithms. And instead, over here in 6 different ways we can differentiate between the machine learning algorithms and the deep learning algorithms. The first one is the data dependence, right? I think Kiran said that we know that the graph between the number of amount of the data and their performance, right?
Sir, is there any separate algorithms for artificial intelligence? Only the machine learning algorithms we can.
No, actually for artificial intelligence we have the feed forward network, feed forward and backward network, recurrent neural networks.
Mechanism only. Using the deep learning or machine learning algorithms, we are executing the artificial intelligence. There is no separate.
No, actually we have a separate artificial intelligence algorithm. AI algorithms.
AI algorithms are there.
Exactly. That's the ANN, artificial neural networks.
Artificial neural networks.
Artificial neural networks.
They are also linked with deep learning and
Exactly, that's what I'm telling. Actually, that's what I showed. Artificial intelligence is the main. There the subset is
an
the
application, sir. Just it is a thought. Yes, just it is a thought. Whether machine can do this or not, just it is a thought. So machine learning and deep learning.
Yeah, by applying that ML and DL, ANN algorithms only, we are
ML and DL will enable AI.
Yeah.
Actually the 1950s and 60s itself there is no that ANN. Artificial neural networks, the algorithms and the feed forward and feed backward forward, etc. models and that. Those are started in the 1950s and 70s itself. Okay, right? So the first one is the data dependency. So as the amount of data is increases, your performance is also increases for the both algorithms, for the machine learning and deep learning. But if suppose the amount of data is less, we are training with a few data samples as compared to deep learning models, the machine learning models will give you the better performance. This is the actual graph. This is for the machine learning and this is for the deep learning. As the amount of data, if the less number of samples we want to train the model, as compared to this deep learning, machine learning algorithms have higher accuracy. As they keep on increasing the data, what will happen in the machine learning models is, if you keep on increasing the data, we have selected the features. The major difference between the machine learning and deep learning is, if you know the domain knowledge, we can go for a machine learning. If you don't know anything about the domain knowledge, we can go for a deep learning. So the meaning is, if you don't know anything, that mission will tries to understand the data and it will take their own data features, so that obviously if the data is increases, more number of experiences will be trained to the model, so that as compared to machine learning, deep learning will give us the better result if the data is increased. But whereas in the machine learning, if you are increased, keep on the data, but what is the main difference between that is, if you keep on increasing the data, but in the machine learning we have already selected some of the features for the data. We are not changing the amount of features, we are just changing the data sample, but features are keep on same. So that as you increase the data, it's already saturated state. So that's the reason why, as the amount of data is increases, as compared to machine learning, deep learning algorithms will give the better results compared to machine learning. So if you have a loose data, and that too if you don't know anything about the data, better we can choose a deep learning model. If you know the complete fundamental, like the domain of that particular data, and we know some statistical features about the data, then we can, if suppose the data is less data, then better we can use the machine learning. This is the first difference between the data dependency from the machine learning and the deep learning model. And the next one is the hardware dependency, right? In a machine learning model, we can use the CPU and
so before going to that, what type of challenges and assumptions are made or considered before building the algorithms or architecture or any model of what are the initial step of challenges and assumptions are considered before going to
I will explain that one with respect to some example.
Okay.
Yeah, with the example I will explain how we can choose a model, right? That's what you right. You're asking the same thing. How we need to challenges.
Yeah, challenges and assumptions. Before going to start to develop any model depends on your application and task. What are the initial assumptions and challenges we kept in your mind?
I will show that. Right? So next one is the hardware dependency. So machine learning algorithms, we are using the CPU, that memory will be less we can use because we know the features. Instead of giving the entire data, I just keep selected some of the features that I can train the model, so it requires less memory. Whereas in a deep learning models, we don't know anything, so we need to give the entire data. So for handling, we need a GPU setup, memory handling will be high. And the next one is the feature engineering. So this is the actual difference between the machine learning and deep learning. In a deep learning, no need to know the domain knowledge. You directly apply the data. But in a machine learning, first we need to analyze the data. This data is related to this particular features or having. So we need to analyze and then we can apply the machine learning. And the next one, problem solving also. In a machine learning, it's a step-by-step process. Object identification, detection, and then classification. It's a step-by-step process. First we need to detect and then we need to classify. Whereas in the deep learning, it's like you don't need to go for a step-by-step. Directly you can give and automatically the layers will get the lower level features and high level features from the data, and the edges, boundaries, whatever the features, and then automatically will use the classification. So problem solving is a step-by-step in a machine learning, whereas in the deep learning it's direct one shot. You can give the data, the neurons will train the model, and it will use the both the low level and high level features, and then we can get the final reports. And the execution times, like for the training and testing, we can divide two parts. For a machine learning algorithms, we can train for hours to weeks, we can train the model. Whereas in a deep learning, it will take weeks to months time, we can, some data it will take. Whereas in the testing, if the fixed data, machine learning algorithms will give a fast outputs. Suppose the data is increases, deep learning will give a faster output. That is the main difference between the machine learning. Testing, training case, machine learning will fast train as compared to deep learning. Whereas in the testing phase, if the data is increases, machine learning will take a larger time to test the data. Whereas in a deep learning, once if you train your model, it will take a larger time to train the model. But in a test case, it will give a faster output as compared to your machine learning. Right? So the next one is the interpretability. That is the major difference between machine learning and deep learning. So that people are moving from the machine learning to deep learning. Because if you know the dollars of the domain, suppose if I want to apply the medical field, so I need to know that what are the features for the diagnosis centers. If I want to apply an agriculture field to machine learning or AI algorithms, I need to know the sum of the knowledge which is related to agriculture. If I want to apply in a speech processing, I need to know what are the features or what are the attributes in the speech signal processing. If I want to apply in a mechanical field, I need to know how the sensors will be working over there. If I want to apply in a EEE electrical department, I need to know the domain knowledge first. If you know the domain knowledge, then we can apply the model and we can get back to the back and we can modify the features also. Right? These are the features are not having the much important as compared to the training, so that I can modify that feature into some other feature. Then it will be possible if and only if you know the domain knowledge. Right? We can modify those features and we can train the model. Whereas in the deep learning, it's not related to your domain and all. We can give a model to that data and it will produce the output. We don't know in an AI algorithm which particular neuron is selecting the particular feature of that particular data. But collectively, all those neurons will be communicated in such a way that we don't know. It's like a background. It's an empirical study and it's a black box. We don't know what neuron will be activated in which epoch and what neuron will be activated in which data, and how we know, like we cannot come back and set the model and we need to changing the parameters. We don't know those things. It's completely black box. But the final thing is, as compared to this ML algorithms, these deep learning algorithms produces the better accuracy. So that interpretability will be possible for the AI algorithms and machine learning algorithms, but deep learning we don't. Because we don't know which neuron will be activated in a particular epoch and which neuron will be producing which type of features also. So that's why people, if you don't know about the domain, you can just go for a deep learning algorithm, you can apply the deep learning algorithm and you can get it. So that is the advantage. So the people, because we don't know why we need to go for a data and we need to set the features and all, better I can apply the deep learning algorithm and it will produce the output. So as the final, I'm getting the higher accuracy, so that this is what happened. Actually, it's a true that interpretability will not be having in the machine learning, deep learning algorithm.
So some problems like, for example, finding some object. If you take tomato and apple, both are seems to be same. So almost size aspect or shape aspect, we cannot distinguish much more. So in that cases, machine learning or deep learning, which algorithms are sized to be better?
Like in my point of view, in that case, better we can go for deep learning.
More features we need.
Like and that too, we need to give a more number of data. See, like if I give a tomato for 10 samples and the apple for 10 samples, those are similar to each other, then no algorithm will use it. See, like sir, like telling these algorithms we try. These algorithms and all we try. If we are unable to discriminate those two, no machine learning and deep learning will be given. Because we are training the machine.
Because we discussed about interpret training. So that is not possible in deep learning.
Yeah, that interpretable is not possible.
Interpretability in the sense,
Analyze that.
we cannot go for new models.
So that. Yes, like my topic is the machine learning, right? So I already said that humans learn from the past experiences, right? From the past experiences we can learn of human brains and that. Like machines follows that instructions, right? Given by the human. If suppose if you train a machine, what will happen? That's what your mission is. If you train that machine, and how it will give it an artificial decision. Right? So the best example we can see here, like taking a small example, like a day-to-day example. We are all using that mobile phones and all. Like if you're opening a YouTube, right? We are seeing one video, and obviously the background will suggest that the same. Like if you're seeing some comedy videos, obviously related videos will come. Right? The same if you are seeing some actress or actors movies, then obviously the related videos will suggest that. Right? These are all nothing but the same AI and algorithms will be working for. Right? You can see that this is an example. Suppose we are listening one song. I'm just giving that how this machine learning will be in a day to day. Suppose we are listening one song. That song we are liking or not. Right? Based on our own past experience, we can tell that. See, like the features I'm taking, the tempo of the song, right? And the generic, and the intensity of that song, and the gender of the voice. It's like a female singer or a male singer, right? I'm just taking the tempo over here, and the intensity over here I'm taking. The tempo will be starting from relaxed mode to and the fast mode, the x-axis, and I'm taking the intensity for light intensity to sorrowing intensity. I'm taking, right? Some of the songs which are having the light intensity and the relaxed mode. These are the songs which are related to those. This cross indicates that these are the songs. So song 1, song 2, song 3 which are related to relaxed mode and as well as the it's a light intensity mode. The same way there are some other songs which is A is, and the same way there is another songs which are related to the fast tempo and as well as the intensity is also stronger. This is the B. A is this song and B is that song. If suppose a new song is playing, right? A new song is playing somewhere over here, right? So these are the songs is liking of, let us say, liking, and these are the songs dislike. We are liking this region, like the relaxed tempo, the light intensity sound. I'm not liking that fast and sorrowing. This is the case of B. If suppose a song is playing over here, right? Now I need to decide that whether it is a liking mode or disliking, right? So how we can tell that? Simply I am taking that there is a circle I am taking from that, and we can see that how many for the disliking, 2, and how many for the liking, 3. Then obviously which one is having it? This is normal example for that. So obviously this song is an unknown song to me, but as compared to my past experiences, these are the songs I am liking and these are the songs I am disliking. So obviously I am having the more votes from the liking case, so that this song is more related to a relaxed mode with a light intensity, so that obviously I'm liking this sound. This is known as the K nearest neighbor algorithm. This is one of the machine learning algorithms. It's a simple way. Is there anything related to CSC people is there? But this algorithm we can call it as a K nearest neighbor algorithm. And with that song, which are all mirror, that I am selecting a case with which one is having the highest voting, that I can choose that new song will be more like to that particular region, so that this is known as the liking song. With the algorithm name is the K nearest neighbor. Right? So if you have that more data I have, then I can go for a better model I can prepare, and obviously it will use the higher accuracy. If I have a more data related to here and more data related to here, I can go for a which are mirror to that particular song, and I can select. Right? So these are the different applications. I think all of you know that nowadays that the Netflix is using for the recommended engines, and like we can use that. And the Facebook, if you are tagging a friend, right? We all know that, right? If you are tagging a Facebook image, if you are moving your cursor to a particular person face, then obviously it will show that this is some X and this is the relation between X and Y, and how many are the common friends between that. If you are moving your cursor to someone in a group of photo, if you are moving a cursor to a particular person face, obviously it will show that what is the details of that particular person, and what are the common friends between you and the person, right? So that one, and this Alexa spam, actually faculty, we know that while we are using the Gmail and all, we don't have that spam personal primaries. We have a single inbox while we are using for Gmail. Only faculty came to know that. Yeah. But the students, they already have that personal primary spam, right? So that is also one of the best examples in that AI and so we are keep on deleting some of the, for example, I have a LinkedIn account, and keep on deleting those accounts. Then obviously, if a new message will come to my mail, which is a LinkedIn account, then obviously it will go to the spam. If you are keep on liking some of the Amazon ads and all, you are opening, every time Amazon ad will come, you are opening and you are seeing, every time that mail will come and you are opening and are seeing that, then obviously treat that Amazon mail is the primary mail to you. That is the actual working for the Google spam sender. And now this health case, diagnostics and all, we are using this AI and the sentiment analysis also, which is very much popular in this COVID case, right? This sentiment analysis center, because in a COVID time, people, we don't know having the exact data of how that COVID data will be analyzed and all. Later they came to CT images, MRI images to analyze that COVID data. But first they started that they are taking the feedback from the COVID patient. Like what is the symptoms of your COVID case? Like what is the symptoms for normal cold and cough? What is the symptoms for the COVID case? What is the how you are feeling but the cold, sneezing, cough and all? Those sentiment analysis they are taking and then analyze the model for the machine learning and all. That is called the sentiment analysis. And the bank transactions, part transactions and all. These are the some of the applications. Sir, you asked that, right? That's this. This is one of the example for predicting the customer journey. It's an example. We need to Uber case. We all know that how we need to predict the cost of the journey. Right? We are booked, right? Rapido, Uber and all. It will not fixed price for the every time. It's not fixed rate for the journey. Right? So it depends upon different pricing in the real time based. One is the demand. Suppose there is some big event is happening in some location. obviously more people are traveling to that particular location, the rate will be increased. So that is one of the key features to change the variable of your price. And next one is the number of cars is available in the particular. Suppose we are booked from the airport to a outskirts of the town. So there is a number of passengers are less to travel in that location. Then obviously what will happen? The car's price will be depending on the number of cars is available in that particular location and the weather. Suppose in the outside rain is happening, right? Then obviously the price will be increased. The same way, rush hours. Like the business, like the morning hours, like 9 to 10, all the offices will be open. So obviously what will happen? The rates will be increased. If you go for a lunch hours, it will be somewhat reduced. So 12 to 1. And if you go for a 1 to 3, it will be less. From 4 to 5, it will be reduced. So these are the features. So based on the real-time features, they change the price of that particular thing. Right? This is also by using the AI and ML algorithms of various standards. This is the best example for real-time AI and ML, how that will be happening. And this is another example, like the weather forecasting using the machine learning algorithms. So still now we discussed that how the machine learning and you can see that first we need to define in the object whether we are predicting a value or whether we are classifying the data, right? That is. And next one is the data gathering and preparing the data explanation, building the model and model evaluation, and then finally we have a prediction. Right? These are the key steps we need to follow to build a machine learning model for anything. And we can either it is a weather forecasting. So obviously what we are trying to predict. Right? And next one, what are the target features for that? And what kind of input data I am taking from that? And next one, what kind of problems I am facing over. These are the primary we need to, what are my objects in that particular situation. And then we need to gather the data. So we are predicting the weather. What are the features we have, what are the attributes we are important to finding that particular one is what is the humidity level and what is the temperature and what is the pressure. These data may be collected from the manually or from the website. But these are the fundamental features or attributes for the data gathering for predicting the weather. The next one is the preparing the data. Once we have a data, it's like we need to clean the data in such a way that is that anything value is missing over the data, and is that any data is corrupted over there. And if you suppose the same data is multiple times repeated, I can remove those data. Right? These are the data preparation for that. And then we need to explain the data. Right? So using some statistical models or the pattern recognition model or the machine learning model. Right? We need to analyze and we need to separate what type of features I need to take from the statistically that particular machine learning model. And then we need to build them. Building means it's a training. Right? Once the training is over, then I need to evaluate the model, whether it is giving a correct output or not. Right? I need to test that model using the validation. If suppose in the validation that I already said that overfitting and underfitting problems, I need to modify, I need to recorrect the data, or I need to recorrect the machine learning model, and to get a final output model evaluation is over, then I can go for a prediction. Right? I can, this is weather prediction, so obviously it's a value. So we can go for it's a regression model. So I can go for a regression model in the machine learning, I can choose that model and I can apply that model. These are the key steps we need to follow for any machine learning model. What is the data, what is the output, and what is the training model, and what is the final.
Prediction is when we go for directly in the model or any.
No, that's what that depends upon we need to go for whether it is an underfitting problem or not.
So that means we need to build the model once again.
That's what. If it is like a underfitting, we need to change the model. If it is overfitting, we need to go for a data and data.
Before the step again
We need
data validation.
Actually, testing a model is a no data. So you get some performance based on the
Just like these are the types we already discussed. One is the supervised, unsupervised, reinforcement, and ensemble. I'll give a quick example for each one. How that in real time. You can see that it's a supervised, it's a labeled data. Suppose I have a billion coins. I have a coins of billion coins. I need to separate in that coin how many are 1 rupee coins and how many are dirhams and how many are US dollar, 1 rupee dollar. Right? So I have a huge coins in my hand. I need to separate. These are 1 rupee coins, these are dirhams, and these are the US dollars. Right? So before that, I already said that it's a machine learning algorithms on the domain basis. So we need to know that 1 rupee coin. So what are the features? The similar, if you see the coin, all are same. It's a round shape. The color are same. Shape is round. We couldn't tell based on the features. Then I have one feature which is having a weight. If it is 1 rupee, I am assuming in that in such a way that the 1 rupee coin is having a 5 gram weight, sorry, 3 gram weight, and a US dollar is a 7 gram, and dirham is a 4 gram. For my assumption, that I checked for that weight, and this is having that weight feature I know, because remaining all features are same to all the like US dollar or rupee or the dirham. So I am taking only thing is the weight matter. So weight is my key attribute or the key feature. I will take that. If I suppose a new coin is in that 1 billion, I can take randomly one coin. I can check the weight. If it is 5 gram weight or 4 gram weight, then obviously what I can came to know that the machine will be directly tell that it is a dirham, because I trained a machine learning model based on the input and output. That is, if a coin is having the 4 gram weight, that we can show that it's a dirham. That like that I can train a model. So obviously, if you can take a randomly any coin from that billion of the coin, I will check the weight, and if it is a 7 gram, I can go for it. Yes.
If it is 3.5,
No coin will be having in that, because
my question is, suppose exactly some 3.5, then again we need to go for another feature.
No, then we can go for another classification.
Another class.
That belongs to this. We can go for, or we can go for another feature. That is like a color, or that is like, or we can go for which one is the nearest one. Which one is like, because in this case 3.5 is the nearest both for 1 rupee and dirham. So we can go for that. Obviously we can tell that it's not a US dollar. Then I can go for another checking between the 1 rupee and the dirham. I will take another feature which is discriminate between those two classes.
So any number of features we can add, sir?
Yes, we can. There is no limit for adding the features. We can.
So suppose so today I build a model so for some data. After 6 months or 1 year, my data is increased. So can I use same model for the next year also, or I need some modification in the model? And the ML or DL?
Present, you have a data and you build a machine learning.
Yes,
model.
that working very well
Yes.
for that data.
Yes.
Next year my data is increased, features are increased, everything is increased. Can I apply same model?
If and only if your data is increasing but the features are same, then we can do the same mistake. If your data is added with a added feature, this machine learning will not work.
Then you need model.
The same way how humans, like we are in a position of learning up to 10th class standard student.
So this
We can
static
give
only,
up
not
to-
time.
Yeah,
The
we can
model.
up to 10th class problem we can solve. Suppose suddenly a like engineering problem, if you give that particular person is not training to that particular problem, even though it's a mathematical problem, But if that, because we are led up to the 10th class standard, we are giving an engineering standard problem. It is also mathematical problem, but it will not. The same way. The machine learning algorithms all are human, how we train that model. That's all.
So same model you cannot use it for always.
No. Right? This is the best example for the supervised case. We know the data and we know the output. If suppose, then another one is the unsupervised. Let us say I am unknown field for the cricket. I am unknown to the sports center. The data is given to me to analyze. And randomly the person is given some data and we can analyze that particular person is a batsman or bowler. I don't know what, completely zero knowledge about the cricket. Right? But I know that XY graph. I know only coordinates. You can see that I am taking that wickets and runs is the key feature, right? I'm just drawing x-axis one features and y-axis another features in the same way, like, because I don't know anything about the sport, but I know the features they are giving in such a way that the runs and wickets to the particular field. I don't know anything. In the previous case, I know this is the weight and this is the coin, this is the weight and this is the coin. But this case, I don't know anything. They gave the Excel sheet to me. These are the wickets and these are the runs. You can tell that the particular person is a bowler and batsman. Right? So I am taking an x-axis is the wickets and y-axis is the runs scored by the particular person. Right? So the wickets is taking more and is scoring the less runs. Some of the players, and some of the players, the wickets are less and is scoring more runs. This star indicates that player. Right? Then I train a model in such a way that this group will be 1 and this group will be 1. Then I can train a model because I don't know anything. Then I can tell that the one player who scores the less runs and taking the more wickets will be treated as a bowler, and the player which is taking the less wickets and scoring the more runs, I can treat it as a batsman. Then a new person score will come and I can put it in the model, right? If suppose the person is having the more wickets, then I can tell that it's a bowler. I'm putting in that. Suppose if a person which is in this region is having the wickets and is having the runs, then the same way I said that we can take a circle, right? And we can note that which is having the both, then I can go for its a algorithm.
Where is your hyperplane like this? Hyperplane?
This for this case. Actually, if it is 2 dimensions, I can go for a line.
Which way? Like this or cutting? I can cut like this.
If you want to tell that how we can
Decision boundaries. Hyperplane.
hyperlink for this.
Line is the hyperline.
Huh?
He's telling the example. Nearest
No. Actually, for this case, the circle we can tell.
Nearest hyperline.
For this case, we can go for a circle.
No decision boundary.
There is no decision boundary because it's not related. We have another case also is available, so that we can't tell that's an hyperlink to separate. If I want to separate purely for the batsman and bowler, then I can go for this is my line. I have only 2 classes, batsman and bowler. I can go for this is my line. But I have in middle, so in that case I didn't have any boundary.
What happened if hyperlane is like this? Hyperlane.
Like this. Then we need to go for the design.
So
The same like
hyperplane designing also one of the challenge.
this is a overfitting problem in that case, or underfitting problem.
You are getting 50% accuracy.
So this type of model we can call it as a unsupervised, right? We don't know anything of the data, and we need to train that model to get an algorithm. The next one is the reinforcement. I already said that we are giving a model as a cat, but it is produced as a dog. And we need to train that model. No, it's not a dog, it's a cat. Keep on, we need to change that model with respect to the feedback. The feedback we give as I said. Till there, no, it's not right, it's not right, it's not right. Change the model. Until we are getting the what we expected. right? That type of model is known as the reinforcement learning, right? We need an agent and we use a feedback mechanism to change that model, right? And another one is the ensemble learning. It's like a mixed. Some weaker algorithms are available. We need to add up one or two weaker algorithms to produce the strongest output. So that type of mechanism is called the ensemble learning. Right? So we have some of the examples for this. Suppose I have a scenario like Facebook recognizing your friend in a picture from your album tagged photos. So we are tagging one photo in a Facebook. If your mouse is moving to there, it's showing that this is the X person and this is the friend relation between those two, and these are the mutual friends for that and that. Which type of case that is? Which type of scenario that is? That is a supervised, unsupervised, or reinforced. Obviously, because we are adding your friend and we are telling the names and all. So we are adding another friend, that names also were added. So we already trained a model. This is belongs to my friend and these are the common friend and this is my tagging. So obviously the first one is the supervised. And next would suppose analyze the bank transactions to tell that whether it is a fraud or not. So which type of that is? Until unless fraud was happened, we don't know whether it is a fraud or not. So obviously this is a unsupervised. We need to analyze the data. These are the mostly likely happened in the previous times, in the last times, so that there may be a chance of this is the fraud transaction. So that is the unsupervised. Now this one. Recommending a new song based on your past music choices. So which type of it? Supervised and as well as which one? It's a supervised and reinforcement. Both. Because you are liking, so the supervised will be coming. And based on that, your feedback is giving to that system a new song that is also related to this, so that it is a supervised and as well as the reinforcement type of learning. Yeah, these are the examples. So supervised, unsupervised, and reinforcement learning, like defining the data and I think I already explained all these things. I just given in a table. And we have a supervised learning. In that supervised learning also we have two types of problems are there. One is the classification and another one is the regression. Right? So classification and regression, these are the two most commonly we are using, and commonly we are putting in the wrong. Right? Classification is the one which is a category. Right? Yes or no, good or bad, left or right. It's like a category. We need to categorize the data. So we need to classify that. That is, we can call it as a classification. Whereas regression, it's a valued output. The output, like for example, we want to predict the weather, right? What is the temperature value today, tomorrow's, based on your past data? What is the price of a particular house in a particular location? Right? Those values and all will come under the regression mode. So classification is the categorical and regression is the valued output. And these are the some of the machine learning algorithms which are related to your classification, Navi-based, random decision, k-nearest, logistic regression, and these are right. And the next, these are the regression algorithms. And next one is the unsupervised. Unsupervised also we have two types. One is the cluster and another one is the association. This one is the cluster based. The features which are similar to that particular, I can group it as a one cluster. The features which are similar to that, I can group it as it's a grouping mechanism for the similar data, that we can call it as a cluster. The association is, we just take a threshold value. If it is reaching, I can associate that particular value to the particular class. That type of mechanisms are known as the association. And for the clustering, these are the techniques are available, and association also the same type of techniques you can use for that. And this is the regression and classification of question. What is the difference between the question? Regression is the valued quantity and classification is the categorical, and this is like a assignment of it. I put at threshold, I can go for that threshold value, I will assign that data. Right? And these are the techniques. I don't want to explain all these things. I will move it to, I will explain the three algorithms. These are the different algorithms which are available for classification, regression, clustering, and all these things. And filtering methods. Yes. Yeah, like in a, I will go for a dimensionality reduction technique algorithm, and then feature extraction technique algorithm, and then I will move to the classification algorithm. So that I will go for explaining the principal component analysis ECA, the linear discriminant analysis of feature extraction, and finally I will explain the SVM, the support vector analysis. These words we commonly familiar with listening that. One is the ECA, LDA, and SVM. This is the dimensionality reduction techniques, and as well as we can go for feature extraction. This is the classification algorithms, right? So you can see that why we need to learn these algorithms and all. So machine learning algorithms or the deep learning algorithms, the major thing is the data. If you have the data, if you want to analyze the data, then we can go for these algorithms. If suppose in a day-to-day life, the digitalized manner, we are having the more data, like we have a more data. Everywhere we are listening the data is this one, data is this one. I'm applying this much GB of data, this much images I'm applying, and I'm calculating the thousands of images to train the model and all. Right? So if you are, suppose if you take an image, what is the pixel size of that particular image? Do you have any idea? If you are taking an image, what is the pixel size? A good quality picture.
1080 by 1080.
1080 by 1080 is the good quality of a picture. Somehow, still there are a lot more quality pictures also. Right? Like 4K by 4K is also one of the images. Better, I am not going for the large number of size of the image. I am just taking an image called a 50 by 50 image. Let us say, just like the 1024 by 1024 is the pixel size. Do you know that pixel size, right? 1024 by 1024 means 1024 row lines and 1024 column lines. That many pixels, and each pixel is having the 0 to 255 pixels black and white. It's a color means same 0 to 255 for the R and 0 to 255 for the G and 0 to 255 for the blue. Right? If suppose I'm taking a single image and that size is a 50 by 50. Right? Simple image. So you know how much is the dimensionality for this? Dimensionality will be like, if you go for a 1, 1, what is the dimensionality? It's a 2 dimensions. We need to represent 1, 1. How many dimensions are required? 2 dimensions. Suppose I can't represent 1, 0, 1. How many dimensions? Now we see that it is a 50 by 50 image. If in a mathematically I can talk, it's a 50 by 50 image can be represented in a vector. It's a, how much is the dimensionality? 50 into 50? That meaning is a small 50 by 50 image is nothing but 2500 dimensions. A small 50 by 50 image is nothing but a 2500 dimensional. Now we can think that a 1024 by 1024 is image. a good quality image, single image, that is 1024 by 1024. Now we can represent it in dimensionality manner. What is the dimensionality? It is, let us say 1000 by 1000. 1000 by 1000. 10 power. It's a 10 power 6 dimensional. You can think that it's a 3 dimensional, we know, right? 2 dimensional, 3 dimensional, 1 dimensional. Now we can think that one single image of a dimensionality of a 10 power 6 dimensional. Now we think that this type of images in a machine learning model, I am taking, let us say, some 5000 images. I am taking to a data of 5000 images of 1024 by 1024. That means is 10 power 6 dimensionality of a images. How many I am taking? 5000. And I need to apply a machine learning model for that. You can think how difficult it is. A simple 50 by 50, let us not go for all these things. A small 50 by 50 image, 50 by 50 means you couldn't see whatever is there in the image. It's a blurred image. That small image, it's a 2500 by 500 dimensionality. We know up to 3 dimensional and 4 dimensional. We can manage the time is over that dimensional. Now we can think that 2500 image dimensionality image, and that type of image I can take 5000 images and we can split it to training and testing the model. If I want to that particular images, we need to train a model. How difficult is that particular machine learning algorithm? So if I want to analyze, for example, I want to go for 1000, better we can go for 10,000 images I need to analyze. It will be happen, like if you go for airport and if you go for airport, you can see that particular person, like this is the person is related to terrorist groups and if you can go for airports or bus station, you can know that face recognition systems are. Nowadays people are doing face recognition and that. The face recognition, if you want to train a model, that minimum how many images we can use it, we can think that. In a face recognition system, in a single bus station or airport, we are applying the face recognition system for the faults and all that. You can think how many images are there trained. It may be go for lakhs of images we need to train. And that too all images in a 10 power 6 dimensional. So this is very difficult to train that model in such a dimensional. So I will apply a machine learning model in such a way that I am not losing the information of that particular image, but I need to reduce the dimensionality in a 2500 by 500 small 50 cross 50 image to some 13 by 1. Or let us say some 15 by 1. From 2500 by 1 to 13 by 1. What is the dimensional reduction is happening here? It's a huge dimensional reduction what happens from 2500 to a 13 or 15. Keeping in mind, I am not losing any information over that. The same 50 by 50 image of a 2500 dimensionality, without losing much information, I can go for a 13 by 1 image which is having the similar features of the same image. I can go for a powerful reduction technique. I can say that it's a powerful reduction techniques that we can call it as a PCA. Principal component analysis. It's a powerful, like everywhere if the dimensional reduction is happening directly, we are blindly we can apply the PCA. It will give the 99% reduction without losing the information of your personality. So all this machine learning and deep learning algorithm people and if you want to analyze the data without losing the data but high data, I can go for a dimensional reduction technique called PCA to reduce my data. You know what logic is happening over here? We already learned all these things in the intermediate level. Not intermediate, I think 9th class itself we learned that logic. Singular value decomposition. Big idea of the thing? SVD. I think 9th or 10th only we learned this. Sorry, let us leave that. I will tell one more name, whether we know that the eigenvalues and eigenvectors. Idea on that? We have eigenvalues and eigenvector. This algorithm is purely based on eigenvalues and eigenvectors. So that's why I'm telling these machine learning and deep learning algorithms is common for all the departments. It's no need to stick for only one department. If you know the eigenvalues and eigendecomposition, eigenvalues and eigenvector, I can apply for this image into this dimension. I can use any machine learning application. Right? I will show in a small example that I'm not going for a much bigger experiment. Better I can simplify this into 50 by 50 image into a small like 2 by 2 image is there. I'm taking a 2 by 2 image. What is the possible dimensional reduction will be happening into 2 by 2? Right? It's a possible only because I have a x1 and x2. It's a 2-dimensional data. What is the possible reduction will be happening? One dimension, because nothing more than that will be happening. I'm taking a small example like it's a 2 by 2 dimensionality, 1 by 2 1. It's a single value decomposition, right? See, there are two vectors are there, x1 and x2. Those are dependent. x1 is the one feature and x2 is the another feature. For a data sample, let us say. These are all the vectors for all like two-dimensional vector. Each cross indicates that corresponding to the x1 component and as well as the x2 component. x1 component and x2 component. So every data sample is a x1 and x2 component is there. How we can measure the dependency of the based on the covariance. Covariance matrices will find the relation between the how much dependency will be there in the two vectors. There's the x1 and x2 vector, how much dependency is there, that will be measured based on the covariance matrices. That is, it is a, let us say this is a x vector, so that is a cx will come, covariance matrices, and that is how we can measure that sigma x1 square, sigma x2 square, rho times of sigma x1, rho times of sigma x2, rho times of sigma x2, rho times of sigma x1, and this is already we know all these things. These are the variances and the correlation coefficient and the covariance matrices. Right? So this is the covariance. By using this covariance matrices, I can measure the relation or the relation the dependency between the two vectors. Right? So I'm taking another vector. This x is having the x1 and x2 components. Right? X is having the two-dimensional one. Now I need to go to measure the y. Right? Y is a single vector, single value. That is how I can measure is a W transpose of x. So what is the x dimensionality? It's a two-dimensional, so the 2 by 1. What is the possibility of dimensionality will be happen in the y? It's a 1 by 1. So what is the W value? It's a 1 by 2. Right? So I can choose a W, a weight matrices, in such a way that it is a 1 by 2, then I can get a scalar quantity of the y. Right? So I need to go for, so y is single value means what we need to find? We need to find the variance. It's a variance of y. This is simply Cy. Cy is just simply nothing but what we will get, sigma y square. This is a single value. Instead of 2 by 2 matrices, I can get a only single value. That's a variance. Right? That variance I am taking in this case as the maximum variance direction. That is the maximum variance direction. I can show that how it will. So what is the covariance formula? It's the expectation of y transpose minus mu y transpose. That is the expectation of covariance formula. We know that what is the y? Y is W transpose x and y transpose is the x transpose W minus mu y is also same like the W transpose of mu x. That's a W transpose of mu x and mu that is mu x transpose of W and we can take the W transpose and W for the both sides, and we can get an expectation inside. It will comes like a W transpose of expectation of XX transpose minus mu x transpose times of W will come. I'm just taking that select linear also. Yes. And then we can, what we will get? It's a W transpose of CXW. You can see that what we are finding, the CY, this is the most important one. The next case I will explain the early here. So CX is the high dimensional. What is the dimensional of CX?
2 by 2.
CX dimensional is 2 by 2. What is the CY dimension? It's a simply 1 by 1. So the meaning is, if any high dimensional data, I can multiply W transpose W in such a way that I can get a low dimensional data.
Transformation.
That is nothing but a high dimensional data will be transformed to low dimensional data if you multiply W transpose and W in the both sides.
That's right.
That one we can call it as a SV. That's a singular value decomposition. That one we can call it as a eigen decomposition. I will show that how the eigen decomposition will come over here. So what my aim is, I need to maximize this covariance. I need to maximize this covariance. How we need to? That is my objective function is that I need to maximize this C1. My objective function is I need to maximize that C1. So that is nothing but I need to maximize this one. I need to maximize this quantity. So like I can go for maximization problem. What I need to do, I will go for a Lagrangian multiplication. I can go for a constraint, and it's like optimization problem now. Right? Simply this objective function is now what will happen? W transpose CXW minus some lambda times of W transpose W minus 1. It's a simple it's a constraint. The weight constraint I am taking, and lambda is the Lagrangian multiplication, or we can call it as a Lagrangian loss. Right? So this is my constraint. With this constraint, I need to maximize this CX, the objective function. How we can find the one maximization or minimization if and only if we differentiate with respect to particular variable and equal to 0. That is the maximization and minimization part. So what I need to do, what I need to find, we can see that if I want to get a lower dimensionality y, I need to multiply W. So that W I need. So I need to differentiate the objective function with respect to that W, and I will equal to 0, then I can get a corresponding W which is corresponding to maximization. So we can differentiate what we will be getting over here. It's a CXW equal to lambda times of W. If I differentiate with respect to W and equal to 0, so what we will get? CXW, and here minus lambda W equal to 0, then I can move that minus lambda W to the right hand side, I will get a this one. Now we can see here this equation. AX equal to lambda x. Have you know that one? AX equal to lambda x. This is the matrices, and these are the eigenvectors corresponding to the eigenvalues. That is what the SV. Right? These matrices, when this will happen, AX equal to lambda x, if and only if for A matrices, this x is the corresponding eigenvectors related to this lambda. So then what is the meaning for this here? It is this W is nothing but it's the eigenvectors corresponding to this particular matrices. For a CX matrices, eigenvectors is nothing but W. What are the eigenvectors? That are the lambdas. For this case, Cx is the 2 by 2 matrices. I already showed that sigma x1 square, rho times of x1, x2, rho times of x2, x1, and x1, x2 square. Then it's a 2 by 2 matrices. How many eigenvalues will get?
2 eigenvalues.
If it is n by n matrices, how many eigenvectors? N by n. So if it is a 2 by 2 eigenvector matrices, how many eigenvalues you will get? 2 eigenvalues. One is This Cx we will having the E1 is the one eigenvector and E2 is the another eigenvector. I will have two eigenvectors which are corresponding to the E1. I will go for lambda 1 and lambda. For this lambda, lambda 1 is corresponding to the E1 and lambda 2 corresponding to the E2. Out of those two eigenvectors, we already know that orthogonality concept. All the eigenvectors are orthogonal to each other, right? So for this case, I have two eigenvectors are getting over here, E1 and E2, which is related to lambda 1 and lambda 2. Out of those two, lambda 1 and lambda 2, I am taking the Cy1 which is having the highest variance. In that direction, this is the direction. That is one of my E1. Then what is the E2 direction? E1, E2 are perpendicular to each other, then that is this one. This is my E2. There are two eigenvectors are coming over the Cx data. That is the lambda 1 corresponding which is having the highest direction of the variance is in this direction. This is the lowest direction in this direction. The second eigenvector. Right? Now we can see that I can project in the data in a highest direction value. That is, I am just writing the parallelly. I'm just drawing this one. This is my E1. This is the highest direction value. I just projected those values. I'm just projecting all these values in this direction. Right? This is which direction? This is E1 direction. Now we can see if I project a particular two-dimensional value in one dimension, what will happen? These are all my projections of the corresponding data. Now we can see that the logic is, the beauty of this algorithm is, actually these data are two-dimensional data. But after the largest eigenvalue corresponding direction we have projected the data, what will happen on this? In a line, what is the representation? It's a value. Initially, it's an x and y axis data. Now, what will happen? It's a simply a point. Point is nothing but which data? It's a single. It's a two-dimensional to one-dimensional will be happening. Now we can think that.
Suppose if it is a one-dimensional data, what will happen? All signals are one-dimensional.
That is the least prediction. That's possible to do. Right? Now, so the data which is simply two-dimensional data, now we can take that it is an m-dimensional data. If it is an m-dimensional data, so I just this one, I will show that what is the. See, like the x is now m-dimensional. What is the meaning of m-dimensional? So the x vector is having the x1, x2, x3, x4 and so on, xn. It's m-dimensional data. Now I want to, if it is m-dimensional data, what is the Cx direction? Cx, this is m-dimensional mean like m by 1. Right? It's a two-dimensional 2 by 1. It's a m-dimensional mean m by 1. If it is a 1000 direction means 1000 by 1. If it is a small 50 by 50, 2500 by 2000 by 1. If it is 1024 by 1024, 10 to the power 6 by 1. Now this is my image. Now that image is in a m-dimensional data. Now what is the Cx? Cx is also m by m dimensional. All the diagonals are the variances. That is the sigma x1 square, sigma x2 square, sigma x3 and so on, sigma xn square. These are diagonal. I am not worried about the co-direction or whatever is the upper or lower. I am only interested about the diagonal because I need to go for the variance. All the variances in the diagonal. That is my Cx. How we need to reduce the dimensionality? Cy. Cy is nothing but what we need to go for? It's a W transpose Cx drive. So before that, what I need to go for? It is a Cx m by m. I will go for the eigendecompose. I will calculate the eigenvalues corresponding Cx. So for this Cx, how many eigenvalues we will get? It's a m by m, so that I will get a lambda 1, lambda 2, lambda 3 and so on, lambda m eigenvalues. I will arrange in such a way that the highest eigenvalue is the first and the second highest eigenvalue is the second. Out of m, the third highest eigenvalue is the third and so on, the m least eigenvalue. I will arrange it in a manner. The highest eigenvalue is the first and next one and go for the last one. So every eigenvalue we have a corresponding eigenvector, right? So that is E1, E2, E3 and so on, En.
Highest value.
For a order, the first one is the highest eigenvalue corresponding highest eigenvector, highest, next highest and so on m. Out of this m, I will choose the eigenvectors which are corresponding to the largest eigenvalue of a n samples, where this n is very much less than value of the n. So this is, let us say this is 1024, I mean like 2500 dimensionality. This is just a 13 samples. Let us say this m is 2500 for a 50 cross 50 image. I can take this n as simply 13 samples or 10 samples, which are having the highest eigenvalues. Because if you can draw these eigenvalues, what will happen? You can see this. This is the actual nature for the eigenvalues. From 0 to 2500 eigenvalues, I can draw it in a manner like which one is the highest one, like that. This is the actual manner of the eigenvalues. We can, if you try that any matrices, we can calculate the eigenvalues and we can plot that eigenvalues. We can get this type of shape. And I can choose that condition. I will choose some 13 or 14 samples, and remaining all which are having the very less value. That eigenvalue is less means that contribution towards the feature extraction is also less. So those eigenvectors I no need to carry forward for the analysis of the dimensional eigenvectors. I will move to the highest eigenvalues corresponding eigenvectors, and I will arrange it in a W in such a way that E1, E2 and so on, E30. Right? Then what will happen? The W transpose is E1, E2 and so on, E30. Now see that what is the E1 dimensionality? What is the E1? Eigenvector. Eigenvector means what is that? What is this eigenvector's dimension? 2500 by 1. That is the eigenvector dimension. What is the second eigenvector? 2500 by 1. This is also 2500 by 1. Overall, what is the dimensionality? It is 2500 by 30. That's a W. Now W transpose means what we will get? 13 by 2500. Now how we will get the Y? Y is the W transpose X, where X is, what is the dimension of X? 2500 by 1. What is the W transpose? 13 by 2500. And what is the Y dimension we will get? 13 by 1. See that. If I will take any image X, that is the dimension of 2500, I can just multiply this W, I can get a 13th dimension of the image. That's why I am telling you, where n is very much less than compared to the m. Right? This will produce us the almost all the key features what we are having in the 2500, because their contribution is very less compared to the eigenvalues. So that's why PCA is the very powerful tool for the image detection. For any like your data problems and I have a used data, what can I do for that data? Just apply the PCA. It's a simply we can call it as it's a pre-processing method for the data. Like we can call it as simply it's a image compression. What we are using overall is just simple linear algebra and then again I am asking that the same question, is it related to any single department? No. So machine learning algorithm, this is one of the examples for that. because all these things we already know from the 1950s onwards. This is the mathematical theories and I'm just applying and proving that this is how the data will be reduced without losing that information. There is a lot of experiences, lot of research papers are there in this also. We can type that PCA, I think almost some thousands of papers will come with that PCA. Even for the past, not even present 2024 papers also PCA is there. We can check it. Some of the faculties which are related to that machine learning and deep learning, even the people before applying the deep learning algorithm, we need to burden that computational complexity for the deep learning algorithm. They are applying PCA as it's a hybrid model. We can call it as a hybrid model. We can apply the PCA and getting the dimensional reduction, and then we can apply the deep learning model, faster execution of the training and that. That is the actual drawback for the deep learning. The training time, it will take large time. Better we can reduce the data and then we can use the data. Instead of giving the 2500 by the dimensionality, I'll just give the 13 by the dimensionality vector. I can train the deep learning model. So this is the PCA. I'm telling this is a powerful tool for the dimensionality reduction, but it will not suitable for the classification process. It will not suitable for the separating the data. I will show that example. Why I am telling this one. Suppose I have two data. This is like this is my, let us say, class 1 and this is class 2. But I said that two data are there. If I can use the PCA, why if you are not using PCA, I will show that example, then I will move to the drawback. If you are not using PCA, how we need to get a dimensional reduction, you can see there. What is the PCA will do? It will go for the maximum variance direction. That is your first eigenvector. If you use the PCA, that will happen. If suppose we are not using PCA and we just apply some other algorithm to draw a line and we can project that data. Suppose I am taking this line I am taking. This is I am taking the direction and I am just projecting the data. Now we can project this data. This one your class 1 data. Now what is the class 2 data? This is your class 2 data. So what will happen over here? The same data samples from the class 1 what you have projected in the direction, the same class 2 also projected in the same direction. Dimensionality is reduced, but is it right way to dimensional reduction? The one which, what is the dimensional reduction will be happen in is the maximum variance will be happen over here, so that I can project this data over here. I can get a good separation between the class 1 and class 2, and as well as the dimensionality also from 2-dimensional to 1-dimensional will be happening. That's why we will use the PCA for the eigenvalue decomposition. Right? If suppose we have another class over here. Class 1, class 2, class 3. So obviously if you apply the PCA, maximum variance will be happening in the same direction, so that it is showing the same direction. Then we can project the data. The real problem. Actually it is happening from the 2 to 1 dimensional is correct. Dimensional reduction is happened. But it is a good for the classification. Previously we can have a separation so that we can classify the data. Now is it right way to classification application? But it is true that the dimensionality will be happen correctly. From the 2 to 1 dimension, dimensionality is happen correctly. But it is not suitable for the classification. Right? So it is not suitable for the feature extraction. It will suitable for the dimensionality reduction. It will not suitable for the feature extraction and the classification. For that purpose, we are using another algorithm called LD, linear discriminant analysis. We can call it as a linear discriminant analysis. The name itself, you draw linear lines to discriminate the data. So we can call it as a linear discriminant analysis. That is the next one. Yeah, this is the guaranteed for the class separation also will be happen over here. Yes, you can see that. So we have RGB. RGB 3 classes are there. Let us see. We have 3 different classes, and we need to apply that the class separation is also happen at the same time. Dimensional reduction is also happen. That's what class separation and the dimensional reduction, both together we can apply over. So we can call it as the feature extraction for the classes. We can see that we have 3 classes like class 1, class 2, and class 3. Right? So class 1 is having the centroid. Centroid is nothing but whatever the elements are there in that class. Right? So the elements in this class, there's a C1, the mu is there, right? The mu indicates that the elements, let us say all these are the elements in this class. Out of all the samples, I am taking the average for that. That's a mean value for that. That is the mean. That is nothing but your mu1. And the same way for the second class, there is all samples are there over here. Those are all the different dimensionality samples. And for that, we are calculating the centroid value is that one. That is for your mu. And there is another class. We have this class. In that average value, we are taking as a mu. Right? Now there is 2 concepts over here. One is the between class and another one is the within class category. Right? So before you can see that the idea of this algorithm is, the idea of this LDA is when we need to separate the data without having any discrimination, we need to separate the data. So the idea is, these are the centroids of the 3 classes. There are 2 terms I am taking. One is the between class and another one is the within class. One is the between class and another one is the within class. See, between this class, so I need to separate a lines for that to separate the 3 different data. Suppose all these vectors are close to each other. All these vectors are close to each other, then we can call it as a, I will write an expression. Right. So you can see here, there is one is the between and another one is the within the class. The logic is, the classes are there, 3 classes. I need to separate the each class apart from the each. This class to this class, as much distance I can separate, and this to this as much apart from the each other, and this to this as much apart from the each class. One class to another class, how much possible distance I can have it, I can apart from the each other. So that what is the condition is, the variance between these 2 classes must be high. The difference between those 2 classes must be high. and the distance between those two classes must be 1. That is the variance must be high. So the first one is the between these classes. The CA is the centroid or nothing but mu I. The centroid for this class 1, centroid for this class 1, and centroid for this class 1. With respect to, I am taking another centroid, that the C is a centroid of centroids. The centroid of centroids. So I am taking this is my C1 and this is my C2 and this is my C3. The distance between C1 and C apart from each other, and the distance between C and C2 will be high, and the distance between this will be high. So obviously what will happen, the classes will be apart from each other. So that is the one possible way to between class. Then another possible way is within this class, whatever the samples you are taking, if all those samples are close to each other, this is the class samples, right? If I can take those close samples with as much close as to each other, then obviously the separation will be happening. One is between the classes I can put the variance apart from each other, how much is possible. And second one is within the class, how much is possible to reduce the variances in the possible. That is the within this class. Within the class, this n is the number of samples. Within the class, Xij indicates that ith class jth element. In an ith class, there is jth element with respect to that ith class centroid. So this variance will be how much low as possible as I take within the class. Between the classes, how much possible I can take, that much high. Then I can form an objective function in such a way that the ratio of SB by SW, that is, I can go for before SB and SW. SB and SW are the high dimensional scatter matrices. If I want to convert into lower dimensional, what I need to do? Adjust W transpose SBW and the W transpose SWW. The same way CX and CY. If these are the high dimensional, if I want to convert it to lower dimensional, I can just pre and post multiply the W transpose and W. Now what I can take the objective function is, I can go for the trace of so what will happen? SP as much high as possible, SW as much low as possible. So the numerator is high and denominator is high. What is the objective function? Obviously, if an objective function is high, I can take is obviously what will happen. The between the classes is the apart from each other, and the within the classes as close to as each other. Then I can form an objective function. This is taking again same. It's an optimization problem. I can take an Lagrange's multiplication and the constraint, and I can take this objective function. This is also maximize. So how we can maximize? Differentiate with respect to the unknown parameter W and equal to 0. Then what we will get? This is like a SBW is equal to lambda times of SWW will come, and I can just pre and post multiply the SW on the both sides. Then I can go for SW inverse SB is equal to lambda times of W. This we will get. Right? SW inverse of SB, W equal to lambda times of W. Then again it's an eigen problem. This one is the matrices, and these are the eigenvectors corresponding to the lambda. Again the same, whatever the data, we can apply the data to the covariance matrices, and we can apply the SB and SW matrices, and we can find the inverse of SW and SB. And for this matrices, again we can calculate the eigenvalues in the large corresponding to the eigenvectors, the largest eigenvalues corresponding to the eigenvector. Out of the same 2500, we can go for 13 images, and then we can apply this value. We will get the W's. At that W's, we can apply the matrices, and we can get the both dimensionality reduction and as well as the class separation. Both together we can apply. So this we can call it as a linear distribution. There is a lot of research happening in this LDA. There is a two-dimensional LDA circuit. In that, there is a fuzziness is involved in that. There is a fractional weights are involved in that. So a lot of research still now is going on this LDA. Right? We stop this with this. Is there any queries?
Can I see the topic? Sorry.
Yeah. Yeah, any queries? Actually, I have planned to explain the SVM also. So, is there anything programming is involved in that? No. If you understand the basic maths in that, behind the algorithm, it's easy to implement in any language. You can apply in the MATLAB, you can apply in the Python, and that. If you know the logic, you can apply anything. So that's what today's my intention also. So these algorithms, machine learning and deep learning algorithms, these are already the 90s, 50s itself. Those algorithms are there. But people are now they are interested showing towards the algorithms. But these algorithms are available in the 1950s. If you know the fundamental logics of the linear algebra, probability, and vector analysis, we can use these algorithms in any platform we can use, irrespective of the domain departments. So that's why people are nowadays interested. Even for the mechanical people, I gave one lecture in the same topic, machine learning algorithms for the mechanical. The Andaman Institute. So it's like irrespective of the department, we can apply any department in any application. We can, like one of my friends, they are doing the same machine learning algorithm, they are applying in Tekkali. Like in the electrical field domain, they are also using it. Even one of my friends in the mechanical department, he is also doing the controllers based on this like machine learning algorithm. Yeah, controllers they are using this one, and even for the mechanical people, the missions they are running over and over time. They need to find the fault identification of the missions. The solar field also they are using. So these algorithms, like in our department, they are also using the medical department. If you know that algorithms properly, then we can use any domain and any application, irrespective of the particular algorithm. Right? That's what my intention. I already said at the beginning. I'm not discussing anything related to computers and IT departments. I'm just telling the mathematical background of the algorithm. Right? Thank you. Any queries?
Good afternoon to all. On behalf of Atal AICTE team, I am very much thankful to Dr. G. Yogeshwara. Dr. G. Yogeshwara has delivered very good speech on machine learning, examples, types of machine learning, and he also taken some derivations also. So I feel that it may get benefit to all the participants. So once again, on behalf of EC department, so I say a big thanks to Dr. G. Yogesh. Thank you. So token of appreciation, I call HOD sir to present a memento to Dr. G. Yogeshwara.
first floor, second floor.